Hello guys. So here is another question from GATE 2023 based on network theory. So the circuit shown in the figure is initially in the steady state with switch K in open position and K bar in closed condition. So this is the circuit. Here K is open initially and K bar is closed. So this current source with resistor and 100 ohm capacitor forms one network, and here there is another network. And now what happens? The switch K is closed and K bar is open simultaneously. So now they're closing this K and they're opening this out. So now this forms one loop and this is another loop. Just this R I and this I anyway is shorted, so it will not come into picture. So only this loop is of concern. Okay. So it is open in simultaneously at the instant t equal to t1, where t1 is greater than 0. The minimum value of t1 in millisecond such that there is no transient in the voltage across 100 microfarad capacitor. So they are asking at what time t1, if we close this and open this, will this loop remain in the same position? There will not be any transient. Okay, so that is the question. So we are now concerned in this voltage Vc of t. So first let us try to find what happens to it before t1. Okay, so here we have this. So before t1 this is anyway open and this is going to be closed, right? So this part of the circuit is not concerned to us since we are only concerned about Vc. So it is just like a current in parallel with a resistance and a cap, and here the current has the value of sine 1000t. So it is not a DC, it is sine function of it's a sine function of t. So then what you have to do, we can take sine 1000t as my reference and go to the Fourier domain. Okay, so my omega is 1000 here, right? So in Fourier domain, what will be my resistance will be same. My I is 1 here, and my cap, what will be my cap? 1 by j omega c. So this is equal to 1 by j into 1000 into 100 into 10 power minus 6. So this is nothing but 10 power 5 into 10 power minus 6, 10 power minus 1. So it is 10 by j or minus 10j. So this is minus 10j. So what is my equivalent impedance here? It is 10 into minus 10j divided by 10 minus 10j. So this, if we take 10 and cancel it, I'll get minus 10j by 1 minus j. I can multiply this with 1 plus j, 1 plus j. I will get minus 10j plus 10 divided by 1 square plus 1 square. So I'll get this is 2. So 5 minus 5j, right? So this is my z. What will be my Vc then? It is just I into this z. So it is 1 into 5 minus 5j. So my Vc of j omega is 5 minus 5j. So this, if I have to write it in magnitude and angle form, what it will be? Magnitude will be root of 5 square plus 5 square, which is 5 root 2. And my angle will be tan inverse of minus 5 by 5, which is tan inverse of minus 1, which will be minus 45 degree because my sign is negative here. So it is in the fourth quadrant. I'll get minus 45 degree. So we said our reference is sine of 1000t. So Vc of t will be this magnitude. So 5 root 2 sine of 1000t minus 45 degree. So this minus 45 degree is nothing but in radians pi by 4. So this is 5 root 2 sine of 1000t minus pi by 4. I'm writing in radians because this term itself is in radiant. Omega is radians per second and t is in second. So this is in radians, right? So I have to write this also in radians. Okay. So this is my Vc of t. For t less than t1, we still don't know t1. We have to figure it out. Let us see what happened to the circuit for t greater than or equal to t1. So let us go back to the circuit. Let us observe what is happening. So for t greater than t1, what is happening? This one is getting closed. This is getting open, right? If this is getting closed, all of I1 will flow through this. So this part of the circuit we can ignore, right? So whatever current here will only be flowing in this circuit, which will be set by this 5 volt. So this equivalent circuit will be, we have this 5 volt and then this 10 ohm and then this C is 100 microfarad. Okay, this is my equivalent circuit, and we said that there should be no transient in my Vc of t for t greater than or equal to t1. So if we say that if this node is also equal to 5 volt when it is starting at the time of the closure of this K bar, can I say that there will be no current and hence there will be no transient, right? So what it means is, if this cap at some different voltage, what will happen is, let's say it starts from Vc, this circuit will try to take it from Vc to 5 volt with a time constant of tau equal to Rc, this R into C. If it is higher than 5 volt, it will try to decrease it and take it to 5 volt. But if starts from 5 volt only, then I can say that it will remain in 5 volt, right? So I need to find the value of Vc of T1 from the previous equation such that this is equal to 5 volt. Okay, so let us find that. And my minimum such T1 for T1 greater than 0 will give me that minimum value whatever they're asking. Because this is periodic, you will get even if you do it at a T plus T1, still you will arrive at no transient in my Vc. But we need to find the minimum T1, and T1 should be greater than 0. So let us see what that voltage is. So it is sine of 1000t minus pi by 4 is equal to 1 by root 2. Sine inverse of 1 by root 2. So my 1000t minus pi by 4 is equal to, I can say it is 2n pi plus pi by 4, right? So this is in first quadrant, or I can also get n pi minus pi by 4. This is in my second quadrant. So together I can write n pi plus minus 1 whole power n pi by 4. So for n equal to 0, it will be in the first quadrant, pi by 4. N equal to 1, it will be pi minus pi by 4, which is in my second quadrant, and so on, okay? So, but I want the minimum T1. So this is T1. So I have 1000 T1 minus pi by 4 is equal to n pi plus minus 1 whole power n pi by 4. So for T1 to be minimum, I'll take this pi by 4 this side. I want my n to be minimum, but also it should be greater than 0. So that will happen for n equal to 0. Because for my n equal to minus 1, this will be negative and this also will be negative, right? So I'll get a negative number. So I will start with n equal to 0, which is my minimum T1 for T1 greater than 0. So I'll get 1000 T1 is equal to 0 plus pi by 4 plus pi by 4. So my 1000 T1 is equal to pi by 8. So my T1 is equal to pi by 8 millisecond. So in what unit they're asking? So they're asking value of T1 in milliseconds only. So it is pi by 8. So pi by 8 value I can get from the calculator. Again, sorry, this is pi by 4 plus pi by 4. So this is pi by 2, right? So pi by 2, if I know the value of pi up to 3 decimal places, I can directly do it, or I can go with the calculator. So pi is 3.1416 by 2. So this will be 1.5708. So I need only the first 2 decimal places. So it is 1.57 milliseconds. Okay.